Hello and welcome to this first short video in a series of 5 videos with the aim to help you to be ready for the start of A-level chemistry. This video is about writing chemical formulae. Now for A-level chemistry, one of the key parts is to be able to write chemical equations. But so many students lose marks in exam questions because they make a mistake with the chemical formulae that is needed for the chemical equations. So hopefully in this video I'm going to go through a few key points with you so that you won't make those same mistakes. So the first thing to point out is that when writing chemical formulae of elements, molecules and compounds, they have no charge. It is ions that have a charge, not elements, molecules and compounds. So for example, if you are asked to write the formulae of magnesium chloride, you do not include the charges in the top corner. If you do that, then you will not get any marks. So first let's start with elements. So elements, if you are asked to write the formula, you just write the symbol on the periodic table. So for example, what's the chemical formula of sodium? So the chemical formula of sodium is Na. What's the chemical formula of magnesium? Again, you just write the chemical symbol. There are some exceptions though. So for example, hydrogen. If you write the chemical formula of hydrogen, hydrogen is a diatomic molecule and goes round in twos. Similarly, nitrogen is a molecule, oxygen is a molecule, and the whole of group 7 are molecules. So when you write those formulae, then you write them in twos as diatomic molecules. There are a couple of other molecules as well. For example, sulfur. Sulfur goes round as 8 atoms, and phosphorus goes round as a molecule with 4 atoms. Okay, now for ionic compounds. So if you're asked to write the formulae of ionic compounds, for example, sodium chloride. Yep, sodium chloride. So sodium chloride is sodium and chlorine. So you've got the sodium and the chlorine. And then what happens is they form an ion. It's an ionic bond. And group 1, so the thing to remember is group 1 always form +1 ions. And group 2 form +2 ions. And group 3 form +3 ions. Group 7, the halogens, they form -1, group 6 is -2, and group 5 is -3. Why they form those ions, that's a separate video that you can watch later. So let's go back to the example of sodium chloride. So you've got sodium, which is in group 1, and sodium forms a 1+ ion. You've got chlorine, which is in group 7, and forms a 1- ion. So 1+ and 1-, when you put those together, there is no overall charge. 1 sodium, 1 chlorine, that is the formula of sodium chloride. Let's try another example. So if we say magnesium bromide. So magnesium bromide. So we've got magnesium, and magnesium is in group 2. So it forms a 2+ ion. You've got bromine, which is in group 7, and that forms a 1- ion. Now you have to have an overall charge of 0. So we're going to need 2 bromines, 2 bromides. 1-, 2-, 2+ equals 0. So there is 1 magnesium, and there are 2 bromines. So we just write the little 2 down at the bottom like that. 2 bromines, and that is magnesium bromide. Another example, let's try potassium nitride. You could have a go at this yourself. You could pause this video and have a go at writing the chemical formula for potassium nitride. Potassium is in group 1, so that is 1+. Nitrogen is in group 5, so that is 3-. In order to have 0 charge, we're going to need 3 potassiums. K+, like that, and 3-. So overall, we've got 3 potassiums and 1 nitrogen. Another interesting thing to point out here is the "-ide". So when you have "-ide" at the end of the name, that means that it's just the element. It means it's the ion of the element. So we've got nitrogen, and it's the ion of nitrogen. So let's try another example. So let's take aluminium oxide. Aluminium oxide. So we've got aluminium, which is in group 3, therefore 3+ ion. We've got oxygen, which is in group 6, therefore 2- ion. And you need them to have the same overall charge. So we've got 6+, we've got O2-, O2-, so we've got 6-, 6+ is 0 charge. There are 2 aluminiums and there are 3 oxygens, and that's the formula for aluminium oxide. Okay, now those are ions of the elements. There are other common ions that you need to know, which are a little bit more complicated. So for example, this ion, you need to know the formula of this ion. So this is nitrate. Another common ion is this one. Do you know what this one's called? This one is called sulfate. And another common ion is this ion, and that one is called carbonate. Now interestingly, the ending 8 means and oxygen, with oxygen. So you've got nitrogen and oxygen, you've got sulfur and oxygen, carbon and oxygen. Okay, now these can be tricky to remember, but you also need to remember the acids. They are derived from acids. So we have got nitric acid. Yeah, nitric acid, which is an acid you need to know the formula of. And you've got H+ and NO3-. So it's derived from nitric acid. Then you've got sulfate. Yeah, so that's derived from sulfuric acid, H2SO4, sulfuric acid. So you have the 2 H+ and the sulfate ion. And we've got carbonate. Now one way to remember carbonate is maybe from calcium carbonate, limestone, and that's where you've got the calcium ion and the carbonate ion. There's another common ion that you also need to know, a positive ion, and that is the ammonium ion. So this appears a lot in A-level chemistry too, the ammonium ion, derived from ammonia. So if you're asked for the chemical formula of ammonium sulfate, for example, you've got the ammonium ion and you've got the sulfate ion. And it needs to have an overall charge of 0, so we're going to need 2 ammonium ions because you've got ammonium and sulfate. So now when you put this together, you need 2 ammoniums. So there's ammonium, and we need to bracket to hold the 2 elements together. Ammonium sulfate is how you write the formula for ammonium sulfate. Okay, now for covalent molecules, it's a little bit trickier, and often you have to draw a dot and cross diagram, and perhaps you need to study a bit of organic chemistry. So remember that covalent bond is a shared pair of electrons, but there are a few common covalent molecules that come up a lot. So for example, water, super popular. And carbon dioxide, you should know the formula for that. And ammonia is very popular as well, ammonia. And other common covalent molecules that come up a lot are methane. So methane and ozone comes up a few times too, and molecules also like hydrogen peroxide. Hydrogen peroxide. Okay, so I hope you found that useful and helpful. The next video, we're going to be using this information, writing chemical formulae, in order to write chemical equations. So I hope you listen into that video too. Thank you.